Somebody want to help me? What was the first one? Yeah. So, the first... No. I'm talking about current events that I've discussed throughout the semester. So these have already been talked about. Okay? And I say current event 1, current event 2. Okay? So those, one of them was on HPV and the fact that boys no, not boys, but the fact that the mouth is now a place where we're seeing HPV infections.
Oh, okay. Actually, you talk about outside the book.
Well, they are happening outside in the real world. That's why they're current events. Okay, yeah.
Do we need a Scantron?
You will need a Scantron 882E. Scantron 882E. It's the green one. I think. Yeah, that's it right there. Okay, any more questions?
Do any questions come from the book directly?
It's possible because my lectures come from the book directly, so yeah. I mean, the book is certainly going to be a good source, a good supplemental source to the lecture. Absolutely. Any source that you use, it helps you learn the material, for sure.
There's a conflict when we schedule a different time?
No, that's the only time that I'll be giving the exam. Okay, so we were talking about wastewater treatment. Sanitation has been described as the greatest medical breakthrough. Medical breakthrough. Think about that for a minute. Sanitation has led to a huge reduction in infection in our cities. And the reason for that is if you think about how we used to live, it was very easy to come in contact with wastewater. And we talked about this last time. Your wastewater stream has everything that your community has in it going down it. So any disease, any pathogens that are in the community end up in the waste stream. So if you're being exposed to that waste stream, of course then you run the risk of infection. Vibrio cholera, microbe you may be familiar with. There's an E on the end of this. We've heard about it in the news recently. A couple of years ago with the big earthquake in Haiti, we heard about cholera epidemics, and I think nearly 7,000 people in Haiti have died since the cholera outbreak. The first recorded pandemic of cholera took place in 1817. It had probably been around for a while. It is believed to have originated in India, in the Ganges Delta area, and had probably been stewing there for decades, if not hundreds of years. But in the 1800s, it moved, probably being transferred via traffic, people starting to move around the world now, traveling, things like this. We see it finally moving to Europe and to Russia. Our first pandemic causes the death of thousands and thousands of people. We then get another pandemic that shows up around 1831, and then another one that comes in the 1840s, around 1846, this third pandemic. Now, if you remember, right about this time that we hear about Edwin Chadwick starting to champion the need for some kind of sewer system, some kind of sanitation removal, if you will. If you think about the cities of the time, that's the other thing that we have going on here, is people are starting to move to cities now. Populations are starting to increase in these cities, and that means then you've got people crowding into areas. Now, we don't have waste removal going on yet. So where's the waste going? Well, of course, there are huge cesspools that are used as collection. There are these things called dong houses that can be shared by as many as 40 people. So there are privies that are shared by as many as 40 people. And if you are a wealthy person living in a wealthy neighborhood, your privy probably gets cleaned out on a daily basis. At night they come through and they'll clean it out for you. But if you're living in a lower income area, you're living in the slums of New York City, your privy is probably not getting cleaned out on a regular basis. It starts to overflow, and now you've got this raw sewage running into the streets. In addition to that, our form of transportation are horses during this time. So you've got a lot of dung that piles up in the streets too. Serious piles of horse dung in the streets. Again, exposure to microbes here. And it is these pandemic concerns that kind of spurred Edwin Chadwick and England into getting these sewer removal systems into place. During this time, the Thames River was so smelly, if you will. The stench was so great, and the Thames River is a river that runs through London there, that Parliament had to hang curtains of lye, or soaked in lye, on the windows and stuff to be able to do business because the stench was too great. The idea was that there was something in the air from this waste that was causing people to get sick. So we needed to clean up the waste, which would then clean up the air, and we would finally deal with the pandemics that we were incurring. The thing about cholera and the infection here is that it causes vomiting and diarrhea. So it exacerbates the issue. If you're in a house with someone that's got cholera and they're vomiting and they've got diarrhea, and again, you don't really have waste removal. You've got a bucket, right? And so now people in the family are going to get exposed to it. So this just increases the spread of the bacteria. We didn't know, though, that the disease was necessarily caused by a bacterium at the time. They just knew that dirty water could be the source. And it was suspected of that. But then, in 1954, a guy by the name of John Snow sort of put this notion to rest that, in fact, contaminated water can cause infection. What John Snow had noticed in this small little town was that people that were using water from a very specific well were getting sick. Turns out that one of the locals in that area had a newborn that was infected with cholera, and she had been dumping the child's waste and stuff near this well and had contaminated the well. And so now the well had cholera in it, and people were drawing up the water from the well, and so people using water from this well were getting sick. People using wells from other areas in the city were not getting sick. So John Snow took the handle off of the well and, stopped people from using it. And immediately, the disease stopped spreading in that community. So he had shown that it was the contaminated water that was causing the spread of cholera. He was the first one to kind of provide evidence for that. Of course, not everybody's going to buy your story, and so they'll have to corroborate. It may take years, and it did take years for John Snow's theory to catch on, but eventually we did demonstrate that cholera is spread from contaminated water. Now let's look at the microbe itself. So the infection occurs when you ingest contaminated water or contaminated food. You have to drink or eat a lot of microbes, because the microbes are sensitive to acid. They're not going to survive well in your acidic environment of the stomach, and so you have to drink hundreds of thousands of cells, and a few of those cells will pass through the stomach and make it into the small intestine. Once they get into the small intestine, they'll release an exotoxin. And this exotoxin will cause you to secrete electrolytes. So your cells will secrete sodium and potassium and calcium, those electrolytes, into the small intestines, into the large intestines. And what follows those electrolytes? Water. Water follows the electrolytes. So that's where your diarrhea comes from. So you end up with dehydration. Dehydration is usually what kills those that die from cholera infections. The vomiting and the diarrhea can be so severe that you actually have chunks of tissue from the intestines and from the stomach that are being lost. This exotoxin, interestingly enough, is an example of a lysogenic condition. A phage, a virus, has infected Vibrio cholera. Not all strains, but those strains that cause the disease, cause cholera, has been infected by a virus. And so now this virus is responsible for the exotoxin that the bacterium produces. It actually turns out, if we looked at the bacterium, this is Vibrio here, Vibrio cholera, and these structures are called pili. And the virus has the ability to attach and infect the bacterium via the pili. Okay? And so it gets into the bacterium, and now the bacterium DNA is here, and the virus inserts its genetic material into the bacterial DNA. Okay, now this bacterium, when it goes to land